We've reached the most interesting part of the course. After running our simulation, we're ready to interpret the results. This analysis will be done step by step, starting with histograms, a key tool to visualize data variability. What will we analyze first? We'll look at 2 of the 7 output variables found on the outputs sheet. Total project duration in days, cell B3, and total project cost, cell B8. So we generate the histogram. On project duration, we position the cursor on cell B3. We click on the histogram icon. A segmented bar chart will appear showing the 5,000 simulation iterations. The displayed information, a minimum of approximately 134 days, a maximum of approximately 164 days, an average of 149 days, and a median, the 50th percentile, at approximately 149 days. The default percentiles, the 80th and the 95th percentile. To change the percentiles, we close the histogram, we go to parameters, we change them to, for example, the percentile 75th and 90th, and we regenerate the histogram again. Now you'll see 2 blue vertical bars at the 75th percentile at approximately 152 days, meaning that there's a 75% chance the duration of the project is less than or equal to 152 days. And the 90th percentile, approximately at 155 days. It means that 90% chance of the duration of a project being less than or equal to 155 days. Now, how do we customize the histogram? Want more detail? In parameters, change the number of intervals to 99, which is the maximum. Regenerate the histogram. No need to rerun the simulation. The data is the same, but more segmented, allowing for a finer visual analysis. Now, how to analyze total cost? Now we repeat the process for cell B8, total cost. A minimum of approximately $28,700, a maximum of approximately $27,500, an average of $23,800, a 75th percentile of approximately $24,500, and a 90th percentile of approximately $25,200. This gives you a clear view of the cost variability in your project. Now, why do results change with F9? Every time you press F9 recalculation, new random values are generated. So cells from B2 to B8 change. So we don't make decisions based solely on those cells. That's why the analysis is based on the histograms and or the statistics in columns C to H for each one of the variables. With the current data, if we go back to parameters, we can insert an average completion date, for example, at July 28th, 2026 in cell D5, and an average cost of $23,804 in cell D6, which is the appropriate field. These values reflect the effects of uncertainty, risks not yet included. So we conclude. In this lesson, you learn how to use histograms to visualize results, interpret percentiles and averages, customize charts without rerunning simulations, and understand why values change when recalculating the F9 button. In the next lesson, we'll learn how to fully interpret these results and what happens when we include risks in the analysis.